Hi children, how are you all? Welcome to your home school. This is your next session of 9th standard playing with numbers mathematics. Right? In this session, we are going to start with your second exercise, that is exercise 1.2. Okay, look over here children. You have true or false questions for this first main. First problem. Every irrational number is a real number. So think over here children, what are real numbers here? Do you remember? Real numbers are classified into two types, rational and irrational. Again in rational numbers, it is classified into some numbers. What are those children? Natural numbers, whole numbers, and these are integers. These are all comes under rational. The combination of rational and irrational are called as the real numbers. So what you can say here children, every irrational number is a real number. Yes, it is true. Irrational numbers are the part of the real numbers. So look the second question here. Every point on the number line is of the form root m, where m is a natural number. So children, please little bit you have to think this question here. Every point on the number line. So let's do a number line here. Okay. Every point. So what do you get here? Units 1, 2, 3. And this side negative -1, -2, -3. Right? Every point on the number line is of the form root m, square root m. So where m is a natural number. See here, think here children, normal positive numbers you may get square root of any number. But whereas coming to negative or talking to negative numbers, we won't get with the square root of any value. So what do you say children, this one? This is false. Okay, no negative number on a number line, we won't get with a square root of any number. Right? So this one, what we can say, this is a false statement. Coming to your third question here. Every real number is an irrational number. Every real number is an irrational, children. Do you accept? No, real numbers contains both rational and irrational. Every real number is not an irrational. So look here. Suppose let me take any 4 or 5 or any number. So what you can say? This is a rational number and also a real number. But whereas this is not an irrational number. See here, 4 by 1, it is a rational, it cannot become a irrational. So what is your statement here? All real numbers is an irrational number. Question asked. No, all real numbers cannot be irrational. Some numbers are irrational and some are rational. So I won't accept with this statement. So what we can say here children? This is also a false statement. Okay, this is a false statement. So coming to your second main, are the square roots of all positive integers irrational? So let us think here children, all the square roots of positive integers. Let me take 2. Or let me take root 3, root 4, some of the square roots of positive integers. Are the square roots of all positive integers irrational? Yes, this may be irrational. This is irrational. But look here children, root 4, is it irrational? No, we can simplify this root 4. How can you write this root 4 children? 2 square root will be cancelled. What is this 2? 2 is a rational number. So what you can say here, are the square roots of all positive integers irrational? No, some numbers are not irrational. Square root of some numbers. Examples, root 4, root 9, root 16, root 36, root 25. These are all the square root of positive integers where those numbers are not irrational, they become rational. So something sub question asked here. If not, no. We are saying no. All are no. Some are only irrational. If not, give an example of the square root of a number that is a rational number. Already we have given an example here. If you need one more example, you can take square root of 25. I can write this as square root of 5 square. Square and root will be cancelled. You are left with 5, where 5 is a rational integer. Look here children, third problem. What's your third problem? Show that root 5 on a number line. What is root 5 children? Root 5 is an irrational number, right? So how do you represent this root 5 on a number line? Before starting this problem, I want to explain you about a right triangle and a Pythagoras formula. How do you apply it? So let me show you here children. Let's take a right angled triangle. You know this, no children? If one angle is 90, then its opposite side is called as the hypotenuse. Okay, so let me mark here A, B, C. If A, B, C is a right triangle, what is Pythagoras theorem statement children? The square of the hypotenuse. Hypotenuse, what is the hypotenuse side here? AC square. The square of the hypotenuse is equal to the sum of the, sum means what children? Addition, sum of the square of the other two sides. Sum of the squares of the other two sides. That is AC square is equal to AB square plus BC square. What is your Pythagoras theorem statement children? Once again I repeat. Square of the any right triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. So now children, why do we use this? How we can apply in our number line? So here, let me say you here. Suppose you need to represent here root 2 children. Okay, suppose your hypotenuse is root 2. So, how do you get your root 2 value? Look here carefully. Root 2 whole square is equal to, how much here? Square and root will be cancelled, 2. 2, how can you get here children? Split this 2. I will split 1 plus 1. I may write it as 1 square, 1 square. That is, AB is equal to 1 unit, BC is equal to 1 unit. So, first let us see how to draw root 2 on a number line here. Then we can go with the root 5. So, look here children roughly. Let me draw a line. Okay. So, now how do you do this one? I am going to take here 0, 1, 2, minus 1, minus 2. Right. So, now this base, consider BC children. I'm going to consider from C. This is C and this is B. This is 1 unit. Okay, base. From here, I need to do a perpendicular line. So, what is the line children? Perpendicular. How do you do perpendicular? Do you know 90 degrees? Without a protractor you can do, or with protractor you can do. Do you know this? What is this? Skiver, right? So, from 1. What you are going to do? From 1, draw an arc, okay, or a semicircle you have done. So now, from here on the number line, mark an angle. It makes 60. Then again from here, you mark 60, right? Now from here itself, above an arc, and from here, cut this arc. So, these two arcs should intersect. So, look here children. Now, what if you need to extend? You get a perpendicular line. How do you get a perpendicular children? Using protractor also you can do. Okay. So, with skiver if you want to do, this is the rule. Put the point at B. Do some arc or semicircle. Yeah, wish children. So, from any one point on the number line, draw with the same measurement, arc, and then lift, do one more arc, and then draw the arc, and from here, draw the arc intersects, then draw a line, that is the bisector makes an angle 90 degree. Okay, So now this is how much, children? 90. Look here now. A. I want a point on this line. How do you get, children, here? Take with a scale 1 centimeter measurement. So 1 centimeter means approximately here I am taking. Look here, children, carefully. So from there to you join. So what is this? Root 2. Okay, same that hypotenuse and that two sides of a right angle triangle you try to draw on this number line. Afterwards, what you are going to do? From 0 to a point. See here, children, 0 to a point. Make that point to extend. See here, this is your root 2 value. This is the way you represent number on a number line. So this is a roughly I have taken for root 2, children. Same manner you can go with root 3. Look here, observe here, root 3 if you take here, root 3 whole square will be 3. So you have to split that number. 3 can be splitted as 2 plus 1. That 2 I can rewrite it as root 2 whole square plus 1. Now shall we proceed our problem? What is the problem here? Show that root 5 on a number line. So take a scale, children, everybody, and draw a straight number line with the scale. Mark points 0, 1, 2, 3, 4. Positive numbers towards right side and negative numbers towards left side. Okay, now what I need to do? First, I should think over right triangle. So let us think over here right triangle, children. This is rough part. Right triangle. So how do you do right triangle? For what you need to draw? Root 5. Root 5. Apply the Pythagoras formula here. So what is that? AC square is equal to AB square plus BC square. Okay, what is root 5 whole square? 5. Split 5. How do you get here? 2 2s are 4, right? So I may split this as 4 plus 1. I can rewrite it as 2 square plus 1 square. So look here, observe here careful. This step is not so easy. Split 5 means you may say 4 plus 1 and you will write a 4 and 1 here. That is wrong, children. The square of a number should be this numbers. What you are splitting, no, those numbers should be square of some other numbers. So 2 square plus 1 square. This is 2, this is 1. So now we got a right triangle measurements. Okay, children. Now what you are going to do? BC. What is a BC measurement here? 1 unit. So start from 0. Okay, 1 unit. Mark this point B, mark this point C. Now, what you need to do? You need to do a perpendicular from B. If you want, you can do with skyway itself, children. So from B, I am going to draw a semicircle. Okay, from the point where it is touching. Look here, not this point. Semicircle touching from there to I have drawn 60 degree. Then again, careful, 60 degree. Don't move the skiver. With same measurement, what you take first. Now, look here where you have drawn arc from there to above one arc, and from this point, cut the arc. Can you see the intersecting part here, children? Can you see here? So what you are going to do now? Can you see the intersecting part, no? Take a scale and neatly extend the perpendicular. Okay, now take scale, measure 2 centimeters. Okay, this is approx, children here. You do properly with your own measurements. So now, what is the measurement here? 2 centimeters, no? So let's take here 2 centimeters, draw a arc. So now, what's your next step? From the arc, join O. This is your right triangle. What is the letter you have to write here? A. So now, what is CA, children? This is root 5. This is root 5, but it's not the value of root 5. Where does the value of root 5 will come? It will be on the number line. Okay. So now from this point to measure, can you measure here where it is cutting this? Arc you measure there and draw a dotted line. Yes, this is the point, children, where you are going to mark root 5. This is the value, or this is the place where irrational number is plotted on a number line. So look here carefully. Root 4 value is 2. Root 5 value will be more than 2. Children, are you observing here on number line? Root 4 is 2. Root 5 will be next to 2. So exactly at correct position you got the value. So now once again I am going to give you this explanation. Listen carefully. Whatever be the irrational number asked, try to frame first right triangle. Suppose any other number, let's take, children, here. Root 10. Just imagine here, root 10 you need to plot on number line. Root 10 is nearer to which number, children? Root 9 means 3, right? After 3, your root 10 will be on number line, right? So from here, what you are going to see? So this is wrong. This we need to clear for the next problem. Root 10 whole square will be, okay, let me do here, children. Root 10 whole square is equal to AB square plus BC square. Root 10 whole square is 10. You need to split 10 such that you should get any perfect square. If not got, no problem. So now 10 can be written as 3 3s are 9 plus 1 1s are 1. That is 9 plus 1. 3 3s are how much, children? 9 plus 1 I can split. So now what are the sides of your right triangle, children? This is 3 and this is 1. So now same manner, one arc, 1 unit, you mark here, draw a perpendicular, then 3 centimeters, draw an arc, then again join, measure, make a semicircle to reach number line. That point is called as the, that is the value of root 10. Okay, children, root 5 exactly we are not plotting on number line. The value of root 5 where you get, that is the place where you mark your irrational number. Okay, children, I hope you all have followed this problem. So you take 3-4 examples of an irrational number and try to do in your buff notes. So look here, children, your fourth problem is too lengthy. Let's read here in your textbook. Classroom activity. Hope you all children, you all feel as if you are in your classroom. Constructing the square root spiral, take a large sheet of paper. So what you are going to do now, children? Take a large sheet of paper. Let's take any A4 or A6 or legal sheet, any paper you take separately. And construct the square root spiral in the following fashion. Okay. Start with the point O. Children, can you see here O? And draw a line segment OP1 of unit length. Unit length means 1 unit, children. So unit length, draw a line segment P1, P2 perpendicular to OP1. So what you are going to do? First take a point anywhere on your paper. Mark O. Okay, from there any 1 unit you take a scale. 1 unit anywhere you draw a line and put a point. Okay, from there do the perpendicular. How do you do, children? Arc, and again cut. Like this you are going to get a perpendicular. So again what you are going to do here? Let's see here. Now draw a line segment P2, P3. Look here. P2, P3 perpendicular to OP. OP2. So look here, children. Where you need to cut this one? Again 1 unit. Okay, perpendicular line you draw, 1 unit, cut an arc or put a point there, from there to join. What you'll get, children? This is a right triangle, right? 117, 117. 1 plus 1 will be 2, and this line hypotenuse value is root 2. Okay, now again, now from P2 to P3, draw perpendicular, same manner, arcs, draw the perpendicular with 1 unit. Okay, you mark a point here. Each having same distance, you need to create a spiral, right? So again 1 centimeter, cut the arc. Okay, so now this is a right triangle, children, hypotenuse, root 3. See other two sides here, children, root 2 whole square is 2, 1 whole square is 1, 1 plus 2 will be 3. Yes, this is correct. Okay, now next step what you are going to do, again take 1 unit. Okay, then from here, suppose if your 1 unit is here, arc means from there to join center. Now calculate, children, root 3 whole square is 3, 1 whole square is 1, 3 plus 1 will be 4. So 4, what is this one? It is square root of 4. Again what you are going to do, children, here? Again, do the perpendicular, take 1 unit, draw an arc, from there to join. So now again observe the right triangle here, hypotenuse, other two sides. Root 4 whole square is 4, 1 whole square is 1. 4 plus 1 will be 5. Then your hypotenuse value is root 5. So I'll give you the clarification here, children. Let's mark this as P4, P5, any one right triangle you take. So let me take your right triangle like this. Or anyway you can write right angle at P4, O, and this is P5. So here you know this P4 to P5 is how much? 1 unit. And OP is how much? OP we don't know. So this OP4 is how much here? Root 4. So automatically you'll get this, children. Apply your Pythagoras formula. OP5 square is equal to this one, 1 whole square, plus this side root 4 whole square. 1 whole square 1, root 4 whole square is 4. 1 plus 4 will be 5. OP5 square is 5. OP5. In order to remove square, you know, no, children, apply square root on other side. Then what will be this value? Root 5. Similarly, again, draw a perpendicular, at 1 unit, mark P6, from this point to join center. Now again, root 5 whole square, 5, 1 ones are 1, 5 plus 1, 6. So look here, children, we are going to get a spiral of all the roots. Okay, roots in the sense all irrational numbers we are constructing as an activity of drawing a spiral. Okay, children, with this we are going to end. So here up to where you need to end here, children? Continuing to complete the spiral to create a beautiful spiral, children. So still you have your problem. You read this. Like this, it continues your spiral up to P1. Again, you have to end the spiral. Okay, do this activity. If possible in notes, you can do in your notes itself, children. If it is not possible, you can do in any paper. Okay, with this, we are going to end our session today. And in the next session, we are going to start with the next exercise. Thank you all.